Welcome to this RCR Wireless News webinar. I'm Martha DeGrasse. Today's topic is the advantages of MPLS for mobile backhaul, and our sponsor is Juniper Networks. Mobile backhaul is sometimes seen just as a means for connecting the access network to the core. But in a world that demands rich, context-aware, multimedia-based user experiences, operators and alternative access vendors need to rethink mobile backhaul network and design it for more than simple transport. This webinar will articulate the advantages of MPLS in the backhaul network, including scalability, resiliency, service restoration, and failure detection, as well as flexible foundation for future service. I'm joined now by David Boland. He's Senior Manager, Service Providers for Juniper Networks. Welcome, David.
Hey, thank you, Martha. Good afternoon, everybody. My name is David Boland, and for the next 45 minutes or 50 minutes, we're going to discuss the advantages of MPLS in the mobile backhaul space. This talk is intended for both technical and non-technical audiences. It provides a contextual framework for MPLS references, and hopefully will demystify some of the unique business and architectural terminology that makes up MPLS mobile backhaul. It's going to focus on the changing service mix and paradigm in mobile backhaul, the nature of mobile dynamics, mobile backhaul architectures, and the evolution of mobile networks to meet the needs and the changing needs and services and of the expectations of subscribers.
Thank you, David. We encourage all attendees to use their dashboard to ask questions during the webinar, and we'll get to as many as we can, time permitting. Juniper will have the ability to follow up afterwards for those that don't get answered today.
Thanks, Martha. So the agenda for today is pretty straightforward. We're going to look at a quick market overview, discuss some of the changing requirements in mobile backhaul. We'll discuss operator segmentation and associated architectures. The idea of one size does not fit all, one configuration does not all fit service providers is important, so we'll discuss the advantages and benefits of Layer 2 and Layer 3 and MPLS. We'll discuss a little bit of the evolution of mobile backhaul and some of the new features and functionalities that you may not be aware of, especially regarding LTE. And then we're going to get into the meat of the topic regarding MPLS for mobile backhaul. Discussion on OAM, network resilience and reliability, MPLS plug-and-play for zero-touch provisioning, the concept of seamless MPLS for connecting domains. We'll do a quick overview of support for legacy 2G and 3G services, and then talk about MPLS as a platform for new services. And then we're going to wrap it up with a quick summary. Most of you may be familiar with the market dynamics and the business cases for MPLS. There are really four key trends that are occurring now and in the backhaul market. The first one is the rollout of mobile 4G and the adoption of smartphones. This is a key driver in mobile backhaul growth. The network is shifting away from circuit-based technology to a more packet-based technology. The amount of capacity per cell site is growing to accommodate more mobile broadband subscribers. And fourthly, following the rollout of LTE macro sites, small cells will be deployed in high population areas. Network intelligence will become increasingly distributed, and backhaul networks will support a wider range of revenue-generating services. In short, mobile broadband usage is going to increase exponentially, and that's going to stress the network. And the adoption and the shift to IP is going to become more and more significant. There are many challenges and requirements that providers will face. Mobile service providers and transport service providers, the challenges will ultimately look at CapEx, OpEx, and revenue for operating and maintaining a high-performance network. Regarding CapEx, we want to have fewer and more powerful devices on the network. In regards to OpEx, we want zero-touch, limited maintenance, automated operations, again, to reduce OpEx. And of course, revenue. We want to increase the value per bit, and we want to be able to differentiate services delivery. And all of these are going to require a unified transport infrastructure. So for mobile backhaul business problems, it's simple. There's been an explosion in mobile backhaul infrastructure requirements. You have requirements for 2G infrastructure and transport in the central office diagram on the right-hand side. You have infrastructure for TDM links, for Ethernet links, ATM links for 2G, 3G, and of course 4G. And at the cell sites, you have an increasing number of technologies that require higher bandwidth. Then, of course, there's the conversion to Ethernet, which requires a lot more IP infrastructure, a lot more than previous technologies required. Many more devices are going to be found at the cell site. There's more radios, more base stations, cell site routers. There's packet over Ethernet for subtending other devices like microwave or Wi-Fi. There's many more platforms in the mobile switching office, or MSO. There's separate ATM and IP aggregation platforms, more and more RNCs, SMLCs, Grandmaster clock sources, customer edge routers, provider edge routers. You get the idea, but there's going to be a different transport networks, usually depending on whether it's TDM, ATM, or Metro Ethernet. The next few slides, I'm going to talk about service provider backhaul architectures. The first one, of course, will be a reference architecture, and then we'll get into three distinct types of MSPs and TSPs. Yeah, so in this mobile backhaul reference architecture, this model, we're depicting that there is a mobile service provider, and on the right-hand side, we're showing the mobility core. Then we have the backhaul provider in the middle, and it could be the same provider, it could be the MSP, or it could be a third-party transport service provider or alternate access provider. And then, of course, on the left-hand side, we have the MSP again. What we're showing here is that the NTEs, or the network termination equipment, essentially manage the demarcation points within the mobile backhaul reference model. And these NTEs, well, they can be there or maybe not. It's optional, and it's purely up to the service provider. It's important to note, though, the component at the very bottom is related to timing and synchronization of the network, which is, of course, critical in LTE. And we won't have enough time to discuss it today. Suffice it to say, it's probably its own webinar, and maybe we'll look at doing one in the future with regards to time and synchronization on LTE networks. But for the rest of the slides, just the representation of GPS, 1588 SYNC-E, or NTP should be apparent as we go. So, as I said, there's really three service models we're going to look at. The first one is a transport service provider that offers an Ethernet service to a mobility service provider. The second will be a transport service provider that offers a mobile backhaul service, and the third, of course, is a mobile service provider who owns the whole shebang. This first architecture is showing that the transport service provider offers an Ethernet service to the MSP. In the top half, you see the MSP, and the line of demarcation is that blue line halfway up. And the MSP, of course, has different technology requirements that they run in their own network. They may deliver wireline services or microwave networks as well, but you also have the RAN sites. And below that blue line, the line of demarcation, is the transport service provider level. And there you have a general purpose Metro Ethernet network. There are gateway elements that they could own. They could own their own NMS and EMS, or they could co-share it with somebody else. But it's important to note the differences in the topologies and the architectures between the transport service provider and the mobile service provider. The second model is similar to the first. However, the blue line of demarcation moves up closer to the top. The second model shows the transport service providers delivering a mobile backhaul service to the MSP. And so what this means is we're moving the line of the networks closer to the RAN, and the TSP is offering a mobile backhaul service as well as a mobile core service to an MSP who essentially owns the edge, and in this case the RAN. So we see how the position of some of the network elements change in this diagram, and you can see the positioning of backhaul services, the gateway nodes, and other transport service provider elements. And lastly, the third model we want to be aware of as we discuss MPLS in the context of mobile backhaul is the MSP that owns, again, everything top to bottom. There is, we see the entire operation is owned by this MSP in this case. There's no transport service provider. You see the MSP has a self-built network. It's a self-managed network, and they can offer all the services in and amongst themselves to various regions and segments of the network, which are, of course, owned by the MSP. Now, hopefully, these models will give you the idea of the differentiation between a MSP and a service provider. And, of course, depending on the type of provider you are or the type of provider I am, we're going to have different needs and requirements, and it's important to understand where Ethernet fits best, where IP fits the best, and where MPLS does so as well. So one size does not fit all. Unfortunately, in the service provider arena, one configuration does not fit all. And so operators need to support multiple network architectures and network roles. It implies there's a lot of tuning of knobs, a lot of options and choices need to be made. And the best option for access will vary from operator to operator depending on their specific needs. The transport service provider in the second model will have a different need from the MSP in the third model. So it's important to know where the value of putting MPLS will be, or where the value of putting Layer 2 Ethernet will be. In a Layer 2 Ethernet network, MAC addresses are used to locate endpoints, and there may be limitations on the size of MAC address tables that constrain the size of the Layer 2 network. Nonetheless, Layer 2 networks provide excellent emulated LAN and line functionality that supports point-to-point, hub and spoke, and other topologies. In Layer 2 networks, an IP address is not used for routing. They learn by flooding the network with addresses, and this can present inherent scaling problems as the network gets bigger, challenges for very large networks. Spanning tree and its derivatives are commonly used to address issues at the small and medium scale size network, but they may not scale up. Using IP addressing, Layer 3 networks provide a larger, more flexible network in comparison to Layer 2. Layer 3 fits very well into mesh networks or ring topologies, point to multi-point and partial mesh architectures, but it may not be the best fit for point-to-point architectures. As operators deploy LTE networks, there are distinctive competitive advantages to Layer 3 infrastructures, and there will be distinctive Layer 2 advantages to infrastructures, all depending on the size and the services that are being supported on them. MPLS also offers a full meshed architecture where any site can communicate directly with any other site without having to run through a host and a hub location first. This is going to be critical as LTE starts to grow because the network configurations will start to shift from point-to-point or hub and spoke to more of a meshed architecture, and MPLS has definite advantages there. So the combination of both IP and MPLS in the network architecture brings advantages to mobile backhaul. Now, the evolution, it's important, I guess, to take a step back and talk about the evolution from where we are in 2G to where we're going in 4G. Regarding the evolution of the mobility function from 3G to 4G, the upper part of the slide shows the significance of the MSO, or the mobile switching office, mobile services offices in a 3G architecture. The larger networks can have hundreds of MSOs, tens of regional data centers, and a handful of national data centers. But as we move to a 4G architecture with LTE and small cell networks, we show that MSOs essentially go away. Maybe they don't go away fully, but their value is diminished. The significance there has been considerably reduced because of the conversion to IP, and the regional data center then becomes more relevant for mobile broadband and, of course, for data processing. The national data centers play an increasingly important role with the advent of IMS voice and the packet core. So the primary topology for an existing 3G network is hub and spoke. You can see it in the top. A couple of the cell sites are connected directly back to the metro network in a hub and spoke fashion. And the communication path is directly to and from the cell site and the mobile switching office with little or no communication directly between the cell sites. In 4G and LTE, the concept of inter-cell site communication is introduced, and a new partial and fully meshed topology requirement for 4G and LTE should be considered when determining if the flat layer 2 network would be sufficient or a routed layer 3 network provides a better option. And in the bottom of the slide, on the left-hand side, you can see partial mesh of the cell sites. We'll get into more mesh in the next slide, or this slide, and talk about the L2 interface. An important feature in LTE is the support for the X2 interface. Traditionally, service providers have built layer 2 backhaul networks and have been pretty well serviced by them. However, as providers prepare their networks for the introduction and accelerated deployment of 4G LTE, they're facing several issues that are driving them to reconsider a layer 2 backhaul network and have them considering the advantages of layer 3 and MPLS for backhaul. And in particular, there are a few requirements to consider in regards to mobile backhaul, X2 interface being one of them. First, the LTE defines a direct interface control channel called the X2 that communicates directly between cell sites or enhanced node Bs. This channel is initially used for signaling and passing user traffic during transitions of handoffs, but however, going forward, the X2 interface or X2 control interface will acquire a more important role in coordinating and synchronizing transmission from adjacent cell sites simultaneously in order to effectively increase data throughput. The LTE antennas are effectively meshed together with the X2 interfaces, and these antennas are not necessarily on the same tower, but could be geographically dispersed. Now, this will require a very low latency interface for communication between the two of them, and typically backhauling an X2 interface over a layer 2 network to a centralized provider edge router and then reversing direction back into the access network doesn't provide the latency that's required. It doesn't provide the delay performance for high-speed dynamic coordination of E-node Bs. So the areas covered by cell sites, the physical geographic area covered by individual cell sites are decreasing, which means more and more cell sites are being deployed, which means more and more communication between E-node Bs is going to take place. The areas, will need to hand off transitional traffic between one area and another, and it's not uncommon for a highly mobile user, say somebody in a car or a bus or a train, to transition across a half a dozen or 7 or 8 mobile cell sites or areas, in a single session. So it's going to be critically important that these handoffs are done in a timely fashion without loss of or fewer interruptions to mobile voice and video services. Now, as mentioned before, the LTE reduces the area covered by individual cells and increases the total number of cells. And this can result in scaling issues for the control plane. Mobile service providers are finding that layer 3 and BGP are attractive ways to address control plane scalability. And this control plane may become a limiting factor in the growth of networks, especially if they are based on layer 2 Ethernet models. Both transport service providers and mobile service providers that own the physical infrastructure need to be aware of the complications introduced by using layer 2 to build E-node B meshes and building a mobile backhaul network that will support wholesale as well as revenue-generating mobile services. Now, the concept of centralized and distributed or both is important. It's the next architectural imperative that we want to discuss, and for a new mobile network, we believe that it's one or the other, but it's in fact both. It's a combination of the both. For example, when you roll out new services, you may like to first have them centralized, and then once adoption takes off, you can distribute the capabilities out closer to the edge and make it more scalable. So in order to do that, you need to have a flexible architecture that will help you start off centrally and then distribute the capabilities. Most operators are likely to launch LTE in this type of fashion. They may start with a few sites and backhaul them to a centralized location, but as those LTE subscribers grow, it becomes more efficient to distribute the intelligence out closer to the network. The X2 interface does not need to be used for the initial deployments of LTE, and connectivity options established between Eden OBs and S gateways and MMEs, they can be minimized. However, when operators scale the LTE network to take advantage or full advantage of the services that it can offer, more service providers will need to distribute the intelligence closer to the edge and increase backhaul performance. The X2 and any connectivity between Eden OBs are core elements that need to be brought into the mix when planning the network layout. So what this means is that the flexibility of the network will be a critical success factor in going forward for service providers. So the question is, do I need MPLS in my mobile backhaul? Well, it's hard to overstate the impact, the positive impact that MPLS has had on service provider networks. The success it's had within the optical core and the edge networks can be attributed to two key qualities. The first is its excellent synergy with IP, which is almost universally adopted technology, and MPLS's versatility. This versatility was evidenced by the wide variety of reasons that MPLS was introduced in the first place: for traffic engineering and enhanced QoS features, for resiliency and fast restoration on network failures, and for convergence of multiple networks on a single infrastructure, and to serve as the foundation for new services. It's little wonder that MPLS has been so successful and that many carriers are now looking to it to achieve the same success in the access network. So a key requirement in all backhaul networks, regardless of whether they're operated by MSPs or TSPs, is the ability to monitor and manage the backhaul and to provide and enforce service level agreements. Straightforward. The OAM functions of MPLS and MPLS-TP are fault detection, connectivity check, connectivity and path verification, fault localization, the example would be loopback, and performance monitoring for delay and loss measurement. Additionally, MPLS tools such as bidirectional forwarding detection, or BFD, LSP ping, and LSP trace have been extended to support OAM functions. These OAM capabilities will help wholesale providers by providing the tools required to measure SLA agreements and to assure their delivery. Network management is essential to ensuring a timely and efficient deployment of any backhaul solution. MPLS basic OAM, including deployment, device configuration, service management, monitoring, diagnostics, and they're the key components to network management. They're critical and they need to be considered in advance. With an increase in the volume of traffic being carried over the backhaul networks, TDM is proving to be expensive to scale and operationally inefficient to manage, especially for backhaul. So core networks have either transitioned to a more efficient packet-switched architecture, or they're in the process of doing so. This creates an additional challenge of managing access networks and core networks, especially if they're using different tools. For backhaul, packet-switched alternatives such as Ethernet or IP MPLS are better equipped to scale and more aligned with the architecture of today's core networks. So in the case where you're a mobile service provider that has the edge and the core, you should consider having a single transport technology across the domains. Now, MPLS provides special reliability and resiliency features for networks. Each cell site supports a large number. Today each cell site supports a large number of services, and that number of services is going to be growing. And the downtime can translate into large revenue loss. Redundancy, therefore, must be part of the network design from cell site across the access and aggregation networks and through the core. Primary and backup paths using MPLS technologies enable two levels of protection. The first is at the tunnel, and the second is at the service. So if a failure occurs, MPLS fast reroute and bidirectional forwarding detection can provide sub 50 millisecond switchover time, which is very, very fast and rivals what's traditionally found in TDM and SONIC. MPLS also has a rich set of field-proven protection and restoration mechanisms, such as LSP fast reroute, pseudo-wire redundancy, path protection. There are enhancements to MPLS-TP for resiliency features by adding OAM triggered protection, which allows the operator to automatically trigger LSP to a second path, and optimizing protection and ring technologies. Ring topologies are critically important because we want to consider that many existing backhaul networks were built on interconnecting rings on circuit switch networks. And therefore, as we expect MPLS and MPLS-TP to replace those circuit switch nodes, we need to be consistent with the network architecture that's already in the ground. May not be applicable for greenfields, but if you're upgrading existing network with facilities that are already out there, you want to be able to match the layout of the facilities. So advanced optimization techniques such as wrapping and steering have been developed also as part of MPLS-TP, and they'll provide efficient protection in ring topologies. Another critically important feature for MPLS usage in mobile backhaul is the concept of MPLS plug-and-play for zero-touch provisioning. With the growth of high-bandwidth data services requiring upgrades to mobile backhaul networks, operators today are increasingly challenged with legacy backhaul architectures that are expensive and inflexible, inefficient, and limited to scale. In addition, they're faced with high operating expenses involved in deploying a large number of cell sites, aggregation sites, service configuration, provisioning, diagnostics, and monitoring of the network. All of it adds up to OpEx and CapEx. So mobile backhaul operators, CSPs and MSPs can significantly reduce network operations by automating certain time-consuming tasks and lowering operating costs by dramatically reducing the complexities of setting up and maintaining backhaul networks. MPLS plug-and-play is an excellent cost reduction option for backhaul, especially considering there are so many devices in the backhaul network. Many more devices than you'll find in the core network. Plug-and-play basically is the ability to install equipment with little or no setup. It reduces the configuration burden and reduces the probability of configuration errors, allows you to get your service up faster and start generating revenue quicker. MPLS plug-and-play streamlines complex, what would have been in the past complex operations, and increase the service velocity for the following functions: error-resilient configuration, scripts to prevent procedural errors and simplify common configurations. We have the ability to auto-discovery VPN endpoints for IP, for pseudo-wire, for VPLS. There's autonomic responses to network conditions. It can happen automatically. Automatic enforcement of security policies, and automatic protection of links and nodes. So layer 3 functionality allows a cell site router to configure itself right out of the box. This, what we call zero-touch provisioning, can be done with little or no manual intervention. It can be done by using the configuration available on a network, on a network configuration server, or locally by using just a USB port. Layer 3 devices can be sent directly from a warehouse to a deployment site without requiring a pre-configuration step. And since the device knows how to fetch its own configuration off the network, it will be available and to be available for remote management. No real tech-savvy personnel need to be deployed to the deployment site to set it up. This allows for mass deployment and rapid deployment of large number of devices for cell site towers. All of these functions raise the intelligence level of a backhaul network, allowing it to be provisioned automatically and greatly simplifying the deployment of MPLS. This functionality lowers operating costs significantly by dramatically reducing the complexities of setting up the cell site tower and the cell site router and maintaining the backhaul network by automating certain time-consuming tasks. MPLS plug-and-play enables operators to reduce operating expenses, reduce configuration errors, and improve the efficiency of the network. Now, the idea of seamless MPLS for network scalability is applicable to large networks or people who have multiple domains within the network. Because the MPLS technology has been deployed in the core for 10 years, it's not surprising that MPLS is being extended to the aggregation network and is now expanding out to the access domain. And there have traditionally been domains or boundaries such as core, aggregation, or access, and these have been used independently and have been fairly complex for service creation across a larger network. However, the complexity has been greatly reduced over the last couple of years with the introduction of seamless MPLS. Seamless MPLS eliminates the domain boundaries by opening and extending the topology so that services can be created anywhere in the network and they can cross MPLS domains rather easily. Seamless MPLS connects and integrates the core and aggregation networks with the backhaul down into a single MPLS domain. And typically, services require static configuration between layers and also must be identified between backhaul and aggregation devices. Seamless MPLS eliminates the interfaces between the devices. So with the number of devices in the backhaul and aggregation networks increasingly growing to hundreds or thousands, keeping access devices and access networks simple and cost-effective is the primary goal with seamless MPLS. There are many advantages for deploying seamless MPLS. With the seamless MPLS architecture, operators can have a single control plane, which of course reduces costs. Another advantage is that services can be deployed faster and from any point in the network. And these factors, again, reduce the cost of centralizing service creation and may increase an operator's competitive position in the market, allowing them to roll services out faster, either to the individual subscriber or to a TSP, or from a TSP to an MSP. So, because so many operators have already deployed separate MPLS domains, automatic connectivity and virtualized node connectivity is becoming a real requirement real fast. Seamless MPLS also provides resiliency and node and link level protection in a dynamic and not just a static fashion. So other approaches like VLANs or static MPLS-TP require some sort of physical or logical or even pseudo-wire configuration. It can be complex and it can be time-consuming to do static configuration. When you have a dynamic control plane and the network is dynamic in nature, a plug-and-play template for service creation is much more valuable in bringing services to market in a more timely fashion. So seamless MPLS enables the customers to migrate from a networking topology to a static network topology to a more flexible service creation delivery model. Now, another beautiful thing about MPLS is its support for legacy services. And this becomes increasingly important when the discussion turns to reducing OpEx in the network. With the increase of bandwidth demand per user, combined with the decrease of average revenue per user over the past few years for 2G and 3G, mobile operators and TSPs need to evolve their mobile backhaul networks to be faster and more efficient, and thereby lowering the cost per bit in the backhaul network. One way to address this is to converge multiple backhaul technologies onto a single unified technology through the backhaul. In a typical service provider network or service provider deployment, the cell site router could have or could aggregate 8 to 10 devices, maybe 12 devices, including 2G base stations, 3G eNodeBs, 2G eNodeBs, 4G eNodeBs. There could be IP video cameras for surveillance, weather and telemetry devices, a lot of equipment out at the cell site. Circuit traffic from TDM and ATM connections can be converted to pseudo-wires across the MPLS on a cell site router for transport across a unified packet backhaul network, reducing the costs of backhaul for the TDM and ATM connections. MPLS pseudo-wires are used as a transport mechanism, again, for both IP Ethernet and hybrid types of mobile backhaul networks. The pseudo-wires themselves can be transported over MPLS LSPs, and the adoption an advantage of using and adopting MPLS for transport pseudo-wires is that it's agnostic, again, to the transport media and more scalable than, say, a pure layer 2 network. And again, MPLS protection schemes ensure faster convergence time and detection time, the times that are traditionally found on a TDM or an ATM backhaul. This is important because as we build out mobile backhaul networks and to support next generation of services, we have to look beyond just voice, SMS, or simple data services. Often, mobile backhaul is simply seen as a means for connecting access networks to the core. However, in a world that demands rich, context-aware, multimedia-based user experiences, we need to rethink the way we design mobile backhaul networks. Therefore, it's imperative to design the mobile backhaul network beyond just transport. Design it once and for all so that operators don't have to go back out to the cell site again and again to upgrade them to meet new service or new user demands. So many people on the call today are network architects, network planners, service creation specialists, or product managers. The backhaul architecture that you're developing for your company will lay the foundation for future revenue streams distinctly different from voice or from SMS or from mere data connectivity. And when you deploy IP or MPLS, it allows you to move up the value stack from providing mere connectivity to delivering a new menu of intelligent services. And once these MPLS and IP hooks are baked into the network, it's going to enable you as the operator to innovate in terms of business models, to orchestrate service control through automation and personalized services where consumers will stick with you and you can reduce overall churn. Now, an IP MPLS network has many advantages over layer 2 networks. Some advantages will benefit the MSP, some the backhaul provider, and some both. The advantages include IP and MPLS's ability to meet latency and QoS and reliability, the value of routing requests locally and not going through a MSO deeper in the network means that time-sensitive services can be delivered at the edge and avoid the latency typically associated with delivery deeper in the network. These services, these new services that can be deployed from the mobile backhaul network or from the cell site include Wi-Fi hotspots, machine-to-machine services. You have localized content. We'll talk a bit about mobile TV and mobile video services over LTE in a second. And then, of course, there's backhaul offload. Regarding Wi-Fi first, it's possible, it's easily possible to subtend access points, Wi-Fi access points off of a cell site router. A macro cell rooftop hub in a high-density environment such as a shopping mall or a parking garage can support other devices via power over Ethernet interfaces. It may be difficult to get power to a certain location, but providing power over Ethernet off of a cell site router, layer 3 cell site router, at a hub site to a access point can be easily done, and then you can move into a new realm of service offerings. Besides Wi-Fi support, you can typically also subtend microwave or small cells. It doesn't need to be only Wi-Fi. Regarding machine-to-machine, when communication is device to device and it's in a close geographic proximity, the traversal of the access or the aggregation network only adds latency to something that doesn't need latency and it doesn't need complexity and it doesn't need cost. So a distributed mobility management architecture using MPLS backhaul can optimize machine-to-machine services. The mobility anchor point can be placed at a cell tower or a local aggregation point, which provides a much improved communication path for subscribers or for machines that are connected to the wireless network. Additionally, we can put localized content closer to the network. With localized egress points, local content could be reached directly instead of traversing the core network. caches can be deployed much closer to the subscriber, and this will, of course, improve experience for video and other types of content. And although caching and distribution can be supported with Layer 2 architectures, as well as Layer 3, the flexibility, the extra flexibility of Layer 3 to route locally allows for proximity routing as well as congestion to be considered and factored into the caching locations or cache selections. Now, this is one of my favorite opportunities, and it's new, but LTE specifications include support for what's called Enhanced Multicast Broadcast Multimedia Services, or EMBMS. And these are designed for delivering services such as mobile TV, or digital radio or digital television. EMBMS is an emerging broadcast technology for LTE that has potentially, they can potentially greatly reduce the cost of distributing popular multimedia content, both for streaming as well as for content delivery during off-peak hours. Content can be stored in mobile device memory and accessed by the subscriber at the time of their choosing. Operators will be able to maximize efficiency when offering services such as live TV, video on demand, podcasts. They can even do software upgrades to a large number of mobile devices or set-top boxes in kind of off-peak hours. No one really needs to know about it or be affected by it. Critical factor in delivering these services is IP multicast and multicast VPNs. These are required to deliver IPTV services, and this allows for optimized replication and routing, which is extremely difficult to achieve in a flat Layer 2 environment. And lastly, backhaul offload. Some operators see little value in carrying specific types of traffic across the core of the network and consuming core bandwidth and consuming access and navigation bandwidth that's costly. And so they'd like to hand it off the traffic to a third party as soon as possible. Layer 2 devices at the cell tower have really no ability to influence a routing decision. And so they really only have one path into the network core. By adding egress points to the cell site or the backhaul, we reduce the distance that traffic must be backhauled in order to be offloaded. There can be ways of doing it with Ethernet virtual circuits, but that's cumbersome and requires, again, static configuration of multiple devices, which is time-consuming and cumbersome and open to human error. So offloading packets from backhaul could represent huge savings in access costs. Layer 2 networks can backhaul to an MTSO or a mobile telephone switching office and then route to the core, while a IP MPLS network can route different services separately and optimally. So I want to wrap it up now with just a quick summary of the value for MPLS in the mobile backhaul network. There is a need going forward for more of a distributed architecture, more of a meshed network at the extreme edge. We saw that with the full and partial mesh requirements for the X2 interface. May not be required at the first rollout, but as LTE becomes more successful, as it's adopted more readily, as smartphones and iPads and tablets are delivered, we're going to see an increasing requirement for service flexibility and scalability at the edge. MPLS offers that. MPLS offers a wide range of troubleshooting and management features and functionality for OAM. It allows for the building blocks to be in the network to deliver service level agreements, and those service level agreements are critically important if you're a transport service provider or a Metro Ethernet service provider delivering a backhaul service for an MSP. The resilience and redundancy built into MPLS and MPLS-TP is a differentiator versus other Layer 2 technologies. Fast reroute capabilities of LSP, sub 50 milliseconds capacity is fast. The ability to switch over to a redundant LSP or backup LSP simultaneously to failure is critically important, especially when you have voice services or high-end video services or smartphones. Scalability. If you're, if you have a small network and you're happy with the network and you don't need much more than point-to-point connections, Ethernet is a great option for you. If you're going across domains or you're building out in different geographical areas, or if you're an MSP who owns the transport as well as the RAN or the edge of the network, scalability is a critical factor. As you start to grow, zero-touch provisioning is critical. Plug-and-play MPLS helps out there. The cell site router comes out of the box, goes in the rack, is powered up, pulls its configuration off the network, is up and running. Legacy services, too, for CapEx and OpEx savings are critical. 2G and 3G aren't going to go away anytime soon. They're there for a duration. Paying backhaul prices or backhaul charges for separate networks is becoming, I wouldn't say wasted money, but it can be combined onto a single backhaul network, and operational savings can be achieved by converging 2 and 3G across MPLS LSP using pseudo wires. There's, of course, OpEx savings by converging these networks. And then a lot of attention needs to be paid to using the network as a platform for future services. The operator is the innovator. And if the hooks are in the network, IP, MPLS hooks are there, more than just backhaul, more than just transport can be delivered from a backhaul network from a cell site tower. You monetize the backhaul network with future services. Again, you want to be able to put the backhaul network in and not have to go back out there, service and support, and upgrade it. So MPLS features and IP features, and capacity, even 10 gig Ethernet supports at the cell site router is going to be critically important. Packet over Ethernet is going to be critically important. Packet over power over Ethernet is going to be critically important at the cell site towers. And these, can include new services like Wi-Fi hotspots, machine-to-machine services, broadcast offload, broadcast services, and backhaul offload. So there's a wide range of future services that are available and can be provisioned off of a MPLS backhaul network. I want to take the time now to thank you for attending today's seminar. We have some time to answer some questions. This is an exciting time in the industry. Every few years there's a window of opportunity where technology comes out and allows us to see fun and new types of services. You can see technology and innovation taking place in the space. So it's fascinating if you're involved in it, and there's a lot more things coming down the road. Martha, I want to turn it back over to you.
We do have about 160 people attending, and we would like to take this opportunity to find out about what type of mobile backhaul is being provided by the people attending today. We have a poll that we can put up for about a minute, if that's okay with you. So this poll will be up for about 30 more seconds. Please go ahead and mark your answers and click submit. All right, we're going to go ahead and close out the poll in about 5 seconds here. All right. Thank you very much. Okay, it looks like Ethernet is the overwhelming winner there. And we do have a question based on that. David, are you ready to start questions?
Sure, absolutely.
Okay, great. So we did have a question based on the use of Ethernet. Our very first question actually was, will a comparison with Ethernet and backhaul be made? Do you want to start there, David?
Sure. I think I hit that early on in the topic, in the webinar. There is both of them are effective transport mediums for backhaul technologies. And depending on the type of service provider you are, depending on the services that are delivered, either one is applicable. In some cases, Ethernet is a great option for point-to-point connectivity and big pipes. In other cases, MPLS is a better alternative. Not one size doesn't fit all, and so there's special design considerations that are going to be needed to be weighed, to make this decision. I think that counseling or consulting with different vendors or different professional services organizations will help you determine what's the better fit for a specific backhaul, Ethernet or MPLS.
Okay, thank you, David. Would you like to move on to the question about centralized network architectures at this time?
Sure.
Okay, as I think you can see, this person was asking about centralized network architectures in large countries like ours. Do they defeat one of the biggest benefits of LTE, low latency?
Oh, that's a great question. So yes, they do. And I guess I jumped a little fast on that. Maybe not, yes, they do. They do not defeat low latency, but as those LTE networks grow, as more subscribers come on or bandwidth is used, then latency is introduced. But the power of centralizing and then distributing is important. The combination of both should be used. If your initial network rollout, it may be easier to get out the door up and running based on a centralized service, and if it's basic voice or maybe even just data communications, then centralized architectures will be great. But as more advanced services or as more subscribers come onto the network, as more bandwidth intensive services or applications are delivered, the idea of distributing will become more and more important. From a centralized perspective, there may be 10, 15 in a very large geographical area, centralized locations. There's not one sitting in the middle of St. Louis someplace that's going to cover the whole North American continent. So you may have, depending on the region, a regional data center. So centralized may be New England or maybe the Southwest. But so there will be a handful of centralized offices. But as more and more services are delivered through LTE and more subscribers come on and bandwidth and more cell site towers via small cells are deployed, the power of distribution is going to be critical.
Okay, thank you. And then I guess our next question is about LTE Advanced and the high amount of data throughput. And the listener wants to know if in those cases it's better to rely on a networking technology closer to the physical layer, if that's going to end up being more cost effective than MPLS.
Okay, that's a great question, and honestly I don't have the answer for that. It's still under development and it's still debatable. So as LTE Advanced rolls out, it's a little bit out further than where we are today. So trials and tests still haven't taken place, and there are two camps that are looking to answer that. One could be MPLS and one could be optical based, but honestly I don't have that answer for you.
Okay, and now I hope this turns out to be a bit of a softball question for you. What are the advantages between Juniper and Cisco?
Oh, both companies have strong IP technology, strong background in MPLS. Both have large install base of service providers, and we both share a lot of the same customers. We're interoperable. So I say that we each are unique in our own way, and I think it's a benefit to anybody who is deploying a next generation network to look at all vendor opportunities and all vendor architectures and to weigh what's best for them. But wherever Cisco is, Juniper is, and wherever Juniper is, Cisco is. We're there.
What's the difference between the MPLS-TP without the control plane and the MPLS-TP with the control plane?
Oh, that's a great question. So there's MPLS-TP. It's been in development for the past couple of years, and one of the benefits of TP is that it has a lot of the same type of TDM or SONET features and functionality and provisioning, and people who are comfortable with transport networks today it's not as far a stretch for them to understand the value of TP. The drawback to the way the MPLS-TP has been developed has been around some of the provisioning of the services and the platforms themselves. MPLS without the control, MPLS-TP without control planes provides a lot of static provisioning. And in a network that is growing or has a lot more devices, it will require a lot more hands-on configuration, a lot more static configuration of the network, which may take a little bit more time to get up and running, or they may be, prone to human error. The advantage of having the control plane is it's more automated and dynamic. So it still has the same OAM and resiliency features and transport features found in MPLS-TP, but with the addition of the control plane, it can be done in a more automatic and dynamic fashion, and networks can be set up faster with less humans touching the equipment and introducing error-prone configurations.
Okay, thank you. And I think the next question is asking about 3GPP standards releases, asking if MPLS is suggested or recommended in those standards.
The MPLS or Ethernet and IP are recommended for LTE and 4G. Actually, it's specifically part of the standard, and you have to have the two. I don't think that there is a specific requirement that calls out MPLS, but MPLS is this beautiful tool that provides you the ability to set up services and provide redundancy and reliability. I'm pretty sure that the 3GPP focuses mostly on the RAN environment and less on the access and aggregation, but I may be a little bit wrong on that. But I believe that that's the case.
Okay, thank you. And do you see macro sites evolving into HetNet hubs?
Absolutely. So first and foremost, the delivery of LTE services are going to be through a macro site. And those macro sites are going to have a handful of customers on them to start off with. As more and more subscribers, like myself, move to a smartphone or to 4G or LTE networks, then the bandwidth or the capacity within that macro site is going to be shared amongst more people. And in order to increase the amount of bandwidth per subscriber, we have to reduce the amount of cells in that site, or increase the amount of cells in that site, reduce the amount of subscribers per cell. One way to do that is to roll out small cell sites off of the larger macro site. And so support for smalls and large are going to be important, especially when we start to grow bandwidth and number of subscribers in the LTE network. And some of the nice things about LTE is the ability to start with a larger cell site, a macro site, and then migrate, smaller cells into them. So there is a migration path for that customer, for the service provider, as customers come on. It's important to remember, too, that as these cell sites come online, and more of them do, interconnecting them is going to become more critical. So instead of backhauling 15, 20, 30, 100, 200, 1,000 cell sites to a centralized location, X2 handoffs between the eNodeBs are going to be more prevalent, and therefore IP and MPLS will become more critical factors to determining network capabilities at that time.
All right, David Boland, Senior Manager for Service Providers, Juniper Networks, thank you very much for organizing this webinar today. I know that everyone has learned a lot. We hope that we can do another one soon. We talked a little bit about timing and synchronization of LTE networks as a possible future topic, so we'll hope to do that at a future date. Again, thank you very much. David, do you have any closing comments?
No, I want to thank everybody for their time today. Like I said just a few minutes ago, this is an exciting time for the mobile backhaul market. It's an exciting time for MSPs and TSPs. There's a lot of growth that's going to happen over the next few years, and it's fun to watch from the beginning.
And thanks to everyone who submitted questions today. We were glad we were able to get to some of them. We do have a record of the other ones and hope to be able to follow up with several of those. This webinar will be available for download starting tomorrow, rcrwireless.com/webinars. Thank you very much for joining us. This will conclude the webinar.